is problem 1 from homework 24, the very last homework. And we have this funky trapezoid thing with a hole in it, and we want to find the moment of inertia about the x-axis that passes through the centroid. And here we go. There it is. Okay, so the first thing we want to do is find out where is the centroid. So we don't have to do it about the. We want to find the y bar, right? So we have to figure out where y bar is going to be. So let's take it, and I'll write part right here. And maybe I should have a plan of attack. That sounds like a good idea. So what I'm going to do is I'm going to take a rectangle, a triangle, and a circle, and remove the circle, right? So I'm going to go rectangle plus triangle minus circle, right there, right? And we're going to call this 1, call that 2, and then we'll call this 3. So, start again. Part 1, 2, and 3. It'd be nice if we could make this all in one table, but I don't know if it's going to fit. I don't think so. So I'm going to make a little line right here, and we'll say the X and the Y and the R right here. So let's see. This rectangle is going to be X. And we'll find the area next, right? And then we will need only the y bar of each a, and then we will need the a I y I bar. Okay, we might be able to fit all of this into one table. I don't know if we're really, really careful. I don't know. Can make it pretty small though. Let's see if it fits. Okay, so xi, it's going to be x2 wide. Let me back this up a little bit. There we go, so we can see, get the big picture here. X, this is going to be 3. It's 3y, and it's y1 tall, so 4. Part 2 is going to be x1 minus x2, so it's going to be 2. And it's going to be the same height, 4, and the circle is going to be 0.75, right? So we want to get the area, and I could do 3 times 4. I believe I can do that. I think so. 12, and this is 8, and this is going to be pi r squared, so 0.75 squared times pi, we get 1.767, and remember it's negative because we're subtracting it. I'll even put a little asterisk next to it to be subtracting. Okay, and yi here is simply going to be 1/2 of this, right? So it's just going to be 2. This yi is going to be y2, or 1.5. Nope, dummy. This is going to be 1.5. This is going to be 1/3 times y1. Well, y1 is 4, so it's 4 over 3. Or is that 1.33333? It sure is 1.333. All right, so let's multiply this. 12 times 2 is 24. And then this 1.3333 times 8 is 10.666667. And then 1.5 times that is a negative 2.651. Right. So if we add all of these up, so first I'm going to subtract that out, and I'm going to add 24. So I get 32.02 or thereabouts. And then this one is 12 minus 8. That's 4. No, 12. That's 20. Sorry. 20, and then 1.767 minus comes out to 18.23. And so we can find that the y bar is going to be 32.02 divided by 18.23. And I think I got that right. 1.756 inches. Now, I really wish I could extend this all the way over, but let's just try to find, let's just try to do this. Okay, well, I'll keep going down under here. Okay, so I'm going to have a part, and let's see, what I would really want to have is the individual eye. Let me try it over here. Let me see if I can fit it over here. I think I can fit it. All right, let's see. Take a risk. Take a chance. Take a chance. Take a chance. I. All right. All right. So the I here is, this one is BH cubed over 12. So the base is X. So that's going to be 3, and that's 4 cubed over 12. And I didn't give myself enough room. Maybe I will wait to draw that until I see how much room I can need. So 3, 4, 3 here times 3 divided by 12, and I get 16. Okay, and now I need, this is going to be base times height divided by BH cubed over 36. Did I get that right? Let me double check. BH cubed over 36. Boom. BH cubed over 36. BH cubed. So base is 2. This is cubed over 36. So I get 2 times 4 raised to 3 times that 2. 36 divide. I get 3.555. And then here, I'm going to get the circle, which is going to be, what do we say? I got to look again. I usually use pi, yeah, okay. So that is 1/4 pi r/4. So 1/4 pi and 0.75 fourth. All right, so 0.75, raise it to the 4, multiply by pi, divide by 4. Let's get a small number. 0.2485. And I need to remind myself that it's negative. All right, so I didn't do a great job of planning this out, because now I need another column. But here I'm going to have my DI. Right, so it's going to be the distance that this thing needs to move from its centroid to this centroid, right? So a lot of times what we need to do is just take this and subtract that and then square it. It doesn't matter. And we're going to, so right here, we're going to have AI DI squared right here. So DI, I can do this in each, I'll do this next to the thing right here. So I have DI is going to be 1.756 minus 2. Or you could think of it the other way around, right? So it's going to be 0.244. And I'm going to square that now, so it didn't matter whether it was positive or negative, and multiply it by the area, which is 12. Boom. And all we have is 0.7144. Okay. And so it didn't move much. This one right here is going to be 1.333 and 1.756. Subtract the 2 and we get 0.4227. And now I'm going to square it. And multiply it by 8. And that comes out to 1.429. 1.429. And then, and I'm going to, these are in my calculation, I'm going to add them together to hit plus. And we add them as my running total to the thing. And now, though, I want to find this one, which is only 1.5. So 1.756 and 1.5 minus, we get 0.256. And we're going to square it. And we're going to multiply it by negative 1.767. And that's a negative number right there. Right? So this should be a negative 0.1158. And I'll add all those up. And I should get 2.028. And then I also add all of these up. So I get 16 and 3.556. But then I need to subtract out the 0.2485. Subtract all that up, and I get 19. I mean, subtract all that, add it all up, 19.31, and then I add those two together. And so now I say that this is going to be 21.34 inches fourthed. And is that what I asked for? I think that's all I asked for. Yeah, moment of inertia about the excited about the centroid. Okay. Well, it'll be good to tell you what say what the centroid is, but we know that the centroid is this far above. How did I do? I don't know. I might have messed this thing up. I'm pretty tired. I'm still a little bit out of it, but I think, I don't know. I haven't got a lot of sleep. But we can sleep in 2 weeks. We can really sleep. Can't we all sleep? So let me see. Let's check it out. In SolidWorks. Hopefully this gets you like kind of back in the mood to do SolidWorks. I hope so. That's a really good life skill to have, man. You can make some coin. You can really make some coin. All right, let's see. This thing looks like that. Come down to there. And that's why we're here, right? Well, to serve mankind too, right? But also to get paid. We gotta get paid. I need to get paid. There we go. And that guy was 3. And he is 4. And he is 1.5 because I gave it the radius. And this is y2? No, yeah, 1.5. And then lastly, this should be x3 is 1.5. So it's 1.5, 1.5, okay. Alright, that looks pretty good. Move my ugly mug out of the way. I guess I can turn off this. Let's say done with that. That's extrude. Doesn't matter how deep we make it. And we'll evaluate and see what we did. Section properties. We need to touch on it first. Recalculate. Let's see. Oh boy. Somebody made a mistake somewhere. That's not good. And about the X, about the centroid. Yeah, it's a little off right there. 20.47. All right, so we're a little off. And we're off this 1.87. Let's take a look and see what some more decimal places. Let's check them out. See how far off we are. 1.874. Okay. Well, let me pause this and troubleshoot, and I'll get back to you and find out what I did wrong. Okay, I found it. The area of a triangle is 1/2 of that, right? That's what you get, 1/2. So that would be 4 right here. So that changes this, that changes that, changes this, changes both of those, and of course it changes this. All right. So that's what you get for not getting enough sleep. So 1.333 times 4, 5.333. So let's see. So I have 16 minus 1.767. That should be 14.23. And 24 and 5.333. I just multiplied them. 2.651, subtract it out, and we get 26.68. 26.68 divided by 14.23. Flip them, divide. We get 1.875 or thereabouts. Okay. So we have to take care of all of these. And, when I get down to that last one right here, I probably should have thought my way through, but I think I got the right result anyway, but I might want to think my way through whether it should be negative or not, but it should be. But we should add it to that and then together subtract it out, so that's totally fine. But let's see, so we have, here is this. Let's subtract out 2 from it. So that ends up being 0.1253 and square it and multiply it by 12. And we get a small number. Interesting. 0.1885. Right? And let's subtract out 1.333333. I get 0.5413 and square that, and we're going to multiply it by 4. So that's 1.172. I can add those to each other. And now I'm going to subtract out 1.767. It's not going to be a lot. And then squaring it, it's going to be even less. And then multiplying it by, I just messed up. Shoot. Yes, I just messed up. Okay. It should be 1.8875, 1.5 minus. So there's the go. There should be the 0.375. That looks reasonable. And then square that and multiply it by 1.767. But now we're going to subtract. Oh, damn. And I wanted to write that number down. 0.375 squared 1.767 times. We have a negative 0.2485. And I already subtracted that out. But let me double check all these. 1.885, 1.172, 0.2485. Yeah, that looks right. Okay. 1.112. This should all be okay. So if I am done with that, I can add in my 19.31 and I get 20.42. Let's check it out and see how we did. 20.42 and 1 point here. Let's check them out. Section properties, 20.42, yay, and 1.875. Okay, well, just gotta be stick-to-itiveness. Stick-to-itiveness is a really big and important engineering trait. And watching this video, really important.